or magnetic particle inspection. MPI is one of the common NDT method which is used to detect the surface and subsurface of the discontinuities of the material. This method can be applied for the magnetic particles such as steel, cast iron, and all stainless steels except austenitic and nickel. Okay, before we start the process, we need to check the equipment first. We set the light level by using the light sensor. We put the light sensor in this, and then we check the light level. The light level is 135 feet candle. The minimum required of light level on the procedure is 1000 lux or 93 feet candle. Okay, firstly we clean the material being inspected by spraying the cleaner. And then we wipe the material, and then we check the adequacy of magnetic particles by using a pi gauge. Firstly, we spray the white contrast paint. We spray on the pi gauge, and then we can also spray on the material being inspected, which is the weld part area. And then we check the adequacy of magnetic particles by spraying the magnetic particles. We also use the yoke to determine the distance between the yoke and the pi gauge. And then we apply the AC yoke, and then we spray the magnetic particles, and when we measure the distance, the effective distance. In this area we can see the magnetic lines, and then we measure the distance between the yoke and the pi gauge, which is 6 centimeter. So this distance we use to determine the distance of the yoke. And then we apply the magnetic particles on the weld area to detect the location of the discontinuities. Apply the AC yoke on the weld area, and then we spray the magnetic particles. The magnetic particles can detect the discontinuous which is perpendicular or 45 degrees to the magnetic flux. And then we blow. In this area we can see that there is indication of discontinuities because the magnetic particles is going back to the area. When we blow the magnetic particles, it going back to this area, and then this is the indication of the discontinuities. And then we continue to the other area. We magnetize, and then we spray the magnetic particles. And then we blow. Okay, you see that the magnetic particles is going back to this area. So there is indication of discontinuities. And yes, we are moving forward to magnetize. Let's apply the magnetic particles again. And then we blow. You see, there is also indication of discontinuities because the magnetic particles is attracted. Okay, I think that is all. We can find some indication of discontinuities. After we have found the indication of discontinuities, we can check that there is magnetic flux on this area by using this tool. We can see the two gauges on this tool, and also on this. Okay. So the final step is we need to demagnetize the particle. And then after we have completed the demagnetizations, and then we check the gauge, and then you can see on this area, also in this area is 0, and then on this area also 0, also 0, this area 0, and then 0. Okay. Okay, so we have completed the process. The main advantage of this process is that the MPI can be applied for the magnetic particle, and then it's very cheap and very easy to be used, and then it's also portable. The major limitation of this process is that magnetic particle inspection is only can be used for the magnetic particle only. It cannot be used for the non-magnetic, and then it's very determined for the cleaning process, and then it cannot determine the depth of the discontinuities. So it's from us. Thank you.